In the previous video, we discussed the second application of dimension analysis, that is to check the validity of a physical equation. We used principle of homogeneity there. What was the principle of homogeneity? A physical equation is valid only if each and every term on either sides of the equation has the same dimensional formula that we discussed in the previous class, principle of homogeneity. That means if x is equal to a plus b minus c plus d etc. whatever plus e whatever it is, if this is a valid physical equation, each term a b c d e etc., each of these terms should have the same dimensional formula and should be the same as that of the dimensional formula of x. From this it is clear that you can add or subtract only those physical quantities which have the same dimensional formula. In other words, you can say that you can add apples to apples and not apples to mangoes. You cannot subtract 10 mangoes from 15 apples. Okay. Now, based on this, I had given you 3 pictures of numericals to be done. 3 pictures containing numericals. I hope you must have all done that. I have not seen any query yet or doubts yet from your side. So I assume that you got all. Anyway, I am going to do 2 out of them. That is the 10th question in the last picture and the 11th one. 10th question was E is equal to b minus x squared upon at, where E is energy, x is distance and t is time. E is energy, x is distance and t is time. We want to find the dimension of A into B. So first you have to find the dimensions of A and B. By homogeneity principle, just now I told you, you can add or subtract only those terms having the same dimensional formula. That means B has got the dimensional formula of x squared. So what is the dimensional formula of B? X squared, x is distance, squared, therefore L2. We got that. Now we want to find the dimensional formula of A, so that we can multiply it with the dimensional formula of B. From this relation, what is A equal to? It is B minus x squared upon E into T. E is energy. So what is the dimensional formula of A? From here, we know that this numerator will have the same dimensional formula L squared, because B into x squared. Energy, what is that? M1 L2 T minus 2 into T, T1. So what is A? M minus 1 L0 L squared L squared. This is going to be T minus 1 and the denominator goes up, it becomes T1. We got the dimensional formula of A. Now we want that of A into B. M minus 1 L0 T1. B we already got L squared. So what do we get here? M minus 1 L2 T1. We got the answer. This is of which one? Question number 10 in the homework which I had given you. Now 11. 11 we have pressure P is equal to A minus T squared upon Bx, and you are asked to find A upon B. As in the earlier case, A and T squared should have the same dimensional formula, or else that's why you can do this. A minus T squared is valid. You can add or subtract only those quantities having same dimensional formula. This is what you want to find. Now therefore, what is the dimensional formula of A? It should be T squared. B from this relation, what is that? B is equal to A minus T squared upon pressure into X. Therefore, what will be the dimensional formula of B? The dimensional formula of B will be A, what was that? What was it? T squared. Pressure, you may make use of the table which I had given you to find the dimensional formula of quantities like this, pressure, energy and all those things. M1, L minus 1, T2 into X, which is distance, L1. Remember that we have A dimensional formula as T squared, okay? Now what is this? B has what? M minus 1, L minus 1, L1, if you become L0. This also T0. This is that of what? B. Now we want A upon B. What was it? A was what? T squared, I suppose, na? Yeah. T squared. B, what is that? M minus 1. I am not putting it 0, 0, 1. So what is this? M1, T2. You may or may not put L0. So we have solved 10 and 11 questions. Now we are going to the third application of dimensional analysis. That is to derive relationship between physical quantities. We are going to derive relationship between physical quantities if we know that one physical quantity depends on certain other physical quantities. Then using principle of homogeneity, we can derive the relation between them. I'll explain that with an example. What is this? Our topic: deriving relationship between physical quantities. Third application. Deriving relationship between physical quantities. Okay, we should know that we should know that a physical quantity depends on other physical quantities. Then how they are related, we are going to find out. Third application. I am explaining that with an example. Here is a simple pendulum. This is the equilibrium position. A simple pendulum consists of a bob, a solid sphere suspended from a rigid support using a string. Okay, if you pull it, displace it through an angle theta and release it, it will start oscillating about this mean position, keeps oscillating. We want the time period of oscillation, that is the time taken to complete one oscillation. We want that value t. Assume that the time period depends on the mass of the bob, length of the pendulum, that is distance from rigid support to center of the bob, angular displacement theta, and acceleration due to gravity. T depends on theta, M, L and G. We want to find a relation between them. Now, let us assume that T depends on theta as T is proportional to theta to the power of A. A can be any value. It depends on mass to the power of B, depends on length to the power of C, directly proportional to G to the power of D. In that case, if you combine this, T is proportional to theta to the power of A, M to the power of B, L to the power of C, G to the power of D, or T is equal to a constant of proportionality, a dimensionless constant of proportionality. Theta to the power of A, M to the power of B, L to the power of C, G to the power of D. If this relation is valid, dimension on LHS should be the same as that on RHS by principle of homogeneity. What is the dimension on LHS? Dimension formula of LHS. LHS means left hand side. Time, that means M0, L0, T1. It is dependent on K is a dimensionless constant, therefore no dimension. Theta also has no dimensions. Angle has no dimension. It's a dimensionless variable, so no dimension for theta. No dimension to the power of A. Mass, M1 to the power of B, L1, length to the power of C. Acceleration, what is that? L1 T minus 2. L1 T minus 2 to the power of D. So what do we have here? M0, L0, T1. Right hand side. M to the power of B, L to the power of C. Opening this, we have plus D, T to the power of minus 2D. Okay. If this equation is valid, the dimension of mass on LHS should be the same as that on RHS. That means B equal to 0, C plus D equal to 0, C plus D equal to 0, minus 2D equal to 1. That means D equal to minus 1 by 2. If D is equal to minus 1 by 2, what is C? C is equal to minus 1 by 2. I take to the right side. C equal to 1 by 2. Now substituting these values, B, D and C. A is already 0 because angle has no dimensions. Substituting these values in this relation, what do we get? T is equal to K, theta is not there, M to the power of 0, L to the power of, what is our C? 1 by 2, G to the power of minus 1 by 2, to the power of 1 by 2 means square root. Therefore, what do we get here? To the power of 0 means 1. Therefore, I get T is equal to K under root of L by G. To the power of half means under root. 1 by 2 means 1 by root of G. From experiments, it is found that K is equal to 2 pi. Therefore, I get T is equal to 2 pi under root of L upon G. I have derived a relation between time period of a simple pendulum, the length of the pendulum and the acceleration due to gravity. It is found that The time period does not depend on the mass of the bob, nor does it depend on theta. This is the third application. We have a number of numericals to be done based on by this method.